Okay, this is the last section in this unit. It's 7.7. We're going to be dealing more with equations and proportional relationships, tables, graphs, all that sort of stuff, putting these things together and reviewing. So you'll notice that this first problem takes up the first full page, and then the next couple problems, they're kind of like a half a page apiece, but we're actually going to do problem number 1 from your assignment. So let's go ahead and take a look at that. I'm going to blow this up so that it's full size, and let's run through and read this. It says the graph below shows a relationship between snacks and calories. Use the graph to complete the table. So we've got the graph sitting right here, and notice that it's nicely labeled. We've got calories on the vertical axis, so this is like the y coordinate. And then over here on the horizontal axis, we've got the number of snacks, so this is like the x coordinate. And then I want you to notice a point right here. I've actually got a dot on it. Other than this one right here, 0, 0, that they've kind of explained down here, the only one that crosses at a really nice point, we call those a convenient point, is this one right here, because it crosses right here at 5, 600. So we're really going to clue in and key in on that one right there. That's going to be a really important one, because none of these others really cross at nice convenient points. That one's a little bit above, that one's a little bit below, so we're really going to key in on that one. So I am going to shrink this down so that we can see the graph and most of the table at the same time. So here's what we're going to do. Again, we're going through and we're taking the information from the graph and putting it in the table and then explaining what it means. So this point right here is 0, 0. So 0, 0, 0 snacks, 0 calories, ordered pair, 0, 0. And the sentence that explains what that means is 0 snacks have 0, 0 calories. So if you don't eat any snacks, you don't take in any calories. That should make sense. Now what they want us to do is they want us to fill in each one of these coordinates right here so that we can complete the ordered pair and then explain what they mean. Now, we could take a guess at one of these. I'm going to blow this up again really quickly. We could take a guess at this one and say, okay, this is going to be 1 comma something, and we could say, okay, if this is 150 and that's kind of in between there, that's probably around 125. But to me it looks like it's a little bit below the center, just like this one's a little bit below that line, that one's a little above the line, and that sort of thing. So we need to be a little bit careful on something like this. Let's see if we can fill in one of these other answers. Sometimes it's a good strategy to go through and do an easier part, even if it's further down than filling this in. So let's grab this one right here. I think everybody would agree that this one is right on that grid line right there, right at that intersection. So this is 5 snacks and 600 calories. So 5 snacks, 600 calories. So we're going to write 5 comma 600. And what it means is 5 snacks have 600 calories. Okay? Now, what's really going to help here is if we figure out the unit rate. We know that this is proportional because it goes through 0, 0 and it makes a straight line. So let's figure out what we've got here. If we've got 5 comma 600, if 5 snacks have 600 calories, let's do the ratio of y over x. So let's do 600 divided by 5. If you throw that into a calculator or do a little bit of cross cancellation, that goes in 12 times. So this would be 120 calories. So if we've got 120 calories per snack, let's go through and see if that looks pretty good. So we said this was about a little less than 125, so that looks pretty good. Let's call that 120. So this would be 120 right here. So 1 comma 120, we'll fill that in. And again, what this means is, because x is the number of snacks and y is the number of calories, so we're going to say 1 snack has 120 calories. Okay, and then we're just going to go through and fill in the rest of them. So this is a little bit less than 250. In fact, if we double this, this is 240. And you'll notice this is like counting by 120 or counting by 12s and then adding a 0 if you want. So this is going to be 360. Let's just double check and make sure that that looks good. Yep, that would be 350 right in the middle there, and it's a little bit higher than that, so that's why we were kind of paying attention to that. This one would be, let's see, 12, 24, 36. This would be 48, add a 0. So we've got 2 comma 240, 3 comma 360, and 4 comma 480, and then counting by that other 120, that would get us up to the 600. So I think we're in really good shape here. Let's go back and let's check this point right here. Let's check 4 comma 484. 480, gosh, that looks good. That's enough below there. It's definitely not 500. And if this is 450, gosh, that looks pretty good there. So I think we've got the right idea here. Now let's just explain what this means. So let's say 2 comma 240, 2 snacks, and I'm gonna abbreviate here. 240 calories. Okay, so those little quote marks, that'll just save us a little bit of time in writing. So this would mean 3 calories have 360 3 snacks have 360 calories. 4 snacks have 480 calories, and of course we wrote the last one already, so we wrote that 5 snacks have 600 calories, so we're in good shape there. Now, this next question is kind of interesting. It says, if C represents the number of calories and S represents the number of snacks, write an equation that shows the relationship between C and S, the calories and the number of snacks. Okay, so let's stop and think about this. In fact, on some of these problems, it will say things like this. Okay, so this is S is snacks, C is calories. What it will do is it will actually give you a variable right here. So I'm going to add another row right here to this, and let's figure out what would go in here. So if we had S snacks, how many calories would that be? Well, here we're asking, how do we go from this number to this number, from the X number to the Y number? So how do we go from here to here, here to here? Well, what we did is we multiplied every single one of them by 120. So if this is S, this is going to be 120 times S. So think about that. 1 times 120 is 120, 2 times 120 is 240, 3 times 120 is 360, and so forth. So if this happened to be a variable, if they happen to say, well, okay, you can do it with numbers, but what if it's a variable? What if we don't tell you how many snacks there are? Can you give me a rule that would tell us how to figure out how many calories there are? So what this says is, if there are S snacks, there are 120 times S calories. So you take the number of snacks you have, multiply it by 120, and that will tell you how many calories there are. So the coordinates of that point would be S, comma, 120S. So that means that S snacks have 120S calories. Now I know that looks kind of funny, but let's come down here and let's think about this for just a second. It says if C represents the number of calories and S represents the number of snacks. And remember, when we're using X and Y, we always put the X coordinate first and the Y coordinate second. But when we write an equation, here's what we're going to do. We want the answer, kind of like the calorie answer, to come first, and we want the S to be on the other side. So in other words, you're going to plug in how many snacks you're going to have, and then this is going to tell us how many calories there are. Well, the cool thing about this is we've already kind of figured this out. This is what C equals. Remember, this is the number of snacks and this is the number of calories. So the number of calories equals 120 times S. So this is the answer for that particular problem. And again, you could use X's and Y's. Like on this one, we could write that the Y coordinate is equal to 120 times the X coordinate. That would work just fine. The Y coordinate is 120 times bigger than the X coordinate. But on this one, they asked us to use C and S. Okay, so make sure you do that. And then it says, what is the unit rate? Well, if you stop and think about it, we already figured out the unit rate for this one. We figured out the unit rate right here. It's 120 calories per snack. Make that look a little bit better. Per snack. So then it says down here, what is the unit rate? So let's go ahead and write it. It's 120 calories per snack. And again, when we say per snack, what we mean is per one snack. That's that unit rate that makes things easy to compare. And then it says highlight the unit rate in your table, the graph, and the equation. So let's go ahead and take a look. Here clearly is our unit rate. We're going to highlight it in the table. Remember, where is the unit rate on the table? It's wherever the 1 is. It's straight up above the 1. So there is the unit rate right there. There's that 1 comma 120. So it's on the graph. In the table, it's this one right here. Okay, unit rate right there. and then in the equation. So of course in the equation it's going to be right there. Okay, so that's kind of the idea. That should get you through the assignment. There might be some that you need to think about a little bit, but that's the basic idea.